Now we'll move to joint E, and again, as we did before, step number one is we need to assume direction for the unknown forces. And in this case, we have the AE. We'll assume a direction for AE, and let that direction be compression towards E, and for EC be also compression. And we said step number two is we need to resolve the forces that are inclined. And in this case, we have both EF and EC, which are unknown. They need to be resolved, as well as the known force, which is AE. That will also need to be resolved. So let's go ahead and resolve these forces into their X and Y components. So this will be the X component for EF, or you can call it FE also, both are fine. And this is the Y component, and for EC this will be the X component, and this will be the Y component. And for EA or AE, this is the X component, and this is the Y component. We'll go ahead and name them also. So here we have EF X component, this is EF Y component, and this is EC Y component, this is EC X component, and this is AE X component, this is AE Y component. This is A. So step number two, of course it is maybe useful to mark the angles also on these lines to be able to relate when we sine and cosine. This is 45 degrees given in the example, and this is also 45 degrees, and of course this is 18.43. So again, back to the two equations of equilibrium that we have: the sum of all forces in X direction equal to 0, and sum of all forces in Y direction equal to 0. Equation number one, equation number two. So we need again to develop an approach as how to resolve this problem. We said we'll choose either X or Y and see whichever has only one unknown in it, we'll use that one. So in this case, let's mark the unknowns. This is unknown, this is unknown, this is unknown, unknown, and this is known, and this is known. So if we say all forces in X direction equal to 0, if we apply that equation, we'll have this be involved, unknown, this will be involved, unknown, and this is known. So we have two unknowns in this equation if we do all forces in X direction equal to 0. Now if we do all forces in Y direction equal to 0, let's see, this is one unknown involved, second unknown involved, this is known, and this is known. So again we have an equation that has two unknowns in it. Now once we know that using either or will give us an equation with two unknowns, we have to use these two unknowns. You have to use these two equations to be able to calculate the first unknown, then move to the second unknown. So we might as well start with the sum of all forces, and either it's up to you, but I will start with the sum of all forces in X direction equal to 0. So let's say all forces, sum of all forces in X direction equal to 0. So in that one we'll have, starting from this positive AEX, so it is plus AEX, and we have this is negative ECX, negative ECX, and we have negative EFX, negative EFX, and no other force is equal to 0. So you have to, so AEX actually is 42.42 cosine 45 degrees, and minus ECX will resolve them, though EC is unknown, so we'll say it is equal to EC multiplied by cosine 45 degrees, and for EFX is equal to EF multiplied by cosine 18.43 degrees is equal to 0. So for this part is equal to plus 30 minus 0.707 EC, and this part is equal to minus 0.948 EF is equal to 0. So as you see here, we have this is unknown and this is unknown. So in this equation we have these two unknowns. So what we'll do is we'll go and isolate one of them. So we could do, I'm going to isolate the EC. So back, I'll bring this EC to this side, so it will become 30 minus 0.948 EF is equal to 0.707 EC. So EC is equal to 30 divided by 0.707 minus 0.948 divided by 0.707, that is EF. So what do I get here? I get EC is equal to 42.42 minus 1.34 EF. So that is an equation that I got here for EC. Now I go and apply the sum of all forces in y direction equal to 0. And in this case I have, starting from here, this is upwards, so it's plus AEY, so it is plus AEY, and this is upwards also, so plus ECY plus ACY, and I have minus 45, that's downwards, minus 45 kilonewton, and I have minus EFY, minus EFY is equal to 0. So AEY is equal to plus 42.42 sine 45 degrees, and plus ECY is equal again to EC sine 45 degrees, and 45 minus 45 minus EF is equal to EF sine 18.43 degrees. Let's take this. So 42 sine 45 is equal to, that is plus 30, and this is plus sine 45 again is equal to 0.707, that is EC, minus 45, and minus sine 18 is equal to 0.316, that is EF is equal to 0. So now this will be equal to minus 45 plus 30 is equal to minus 15, and now I'll substitute. What I will do is I'll substitute any value for EC. What I will do is any value for EC will go for this guy. So make it a bit neater. This will be substituted by this value on this equation. So it will be plus 0.707 multiplied by EC is equal to 42.42 minus 1.34 EF minus 0.316 EF is equal to 0. So once I will open the bracket for this part, be equal to minus 15 plus 30 minus 0.948 EF minus 0.316 EF is equal to 0. Now you see I have only one unknown here in this equation once I substituted the values. So I'll proceed with this. We'll get 15 is equal to 1.263 EF, and EF is equal to 15 divided by 1.263 and is equal to 11.87, that is kilonewton. So the result we got here for EF is positive, and it is 11.87, meaning that the suggested direction for EF, we suggested the direction to be towards the joint, which is compression, is correct. So we'll put here, this is compression. So now we'll need to calculate the value for EC. I will use this equation for, so EC is equal to 42.42 minus 1.34, multiply the value for EF is equal to 11.87, and the answer for that is equal to 26.52 kilonewton. And again, the answer being positive, it means the suggested direction for the force is correct, and the suggested direction for the force EC is going towards the joint, meaning it is compression. The suggested is compression, and because the answer is positive, so it means that this force is compression force. So we'll go ahead and update our sketch to move to the next joint.